So I want to give you guys a little bit of an idea about circular motion, but I want to start from basics. You know why? Because circular motion is very important part of understanding sort of various kinds of mechanical problems. And many students, when they do problems related to circular motion, they actually find those questions very, very difficult. If we have some time at the end of the class, I will give you some problems related to circular motion and you will see. और नहीं time मिलता है, maybe in the next class. But some of my students have told me that when it comes to circular motion, they have been like puzzled since their class 12th. G preparation के time से college से लेकर के even GATE के बच्चों ने मुझे बोला है कि सर सर्कुलर मोशन से रिलेटेड क्वेश्चंस हमें इतना मुश्किल लगता था, वी वर नेवर एबल टू फिगर इट आउट कि कैसे करें. बट आफ्टर आई हैव taught them some very simple steps, things become very, very, very easy. It actually is very easy if you follow certain steps. Problem is that we don't really follow steps. We just think we can figure it out on our own, and then we start imagining अच्छा पार्टिकल ऐसे जा रहा होगा तो ये होगा वो होगा. ऐसा नहीं है. We have to follow some standard instructions. If you guys remember, I gave you some standard instructions in lecture number 2, and if you kind of notice, I have been following these instructions in the last 2 lectures. You know, जब भी हम कोई भी problem करते हैं, I simply try to draw a diagram, and then I try to draw the forces in the various directions. We have been choosing a Cartesian coordinate system till now. Fictitious force में हमने ये additional pseudo force का term add कर दिया. Forces को हम resolve करते हैं, उसके बाद जिधर forces balanced होते हैं उधर equilibrium condition होता है, जिधर unbalanced होता है we apply the Newton's second law, जहाँ पे multiple objects are interacting we apply the Newton's third law. And when we do it in a systematic manner, we are able to understand a particular system in a much better way. We are able to get the right answer. The only thing is going to happen is that we are going to switch from Cartesian coordinates to polar coordinates for the time being, for today's lecture. Okay? And other conditions are going to remain the same. So earlier we used to try to resolve the forces in 2 perpendicular directions. One in the x-axis, the other is the y-axis. But circular motion में हम क्या करेंगे? We will try to resolve the forces in 2 very specific directions. One is the radial direction, the other is the tangential direction. ठीक है? XY पे हम नहीं limited रहेंगे. We will go to a new coordinate system. But before we go there, before we look at those kinds of problems, we need to understand something regarding the polar coordinate system in general. ठीक है? बहुत कम बच्चे होते हैं who are very much sort of used to the polar coordinate system. So let us spend some time, maybe an hour, hour and a half, discussing the polar coordinates and, more importantly, the transformation equations which are related to various physical quantities. For example, position, for example, velocity, for example, acceleration, and how that affects the force laws. Force laws में affect क्या पड़ता है? For example, if I tell you the Newton's second law, right? You guys are familiar with the Newton's second law. And you know that the Newton's second law is a very simple mathematical expression. So if we write down because it's a vector equation, if we write down the force equation in 3 distinct directions along x, y, and z, so I can say, okay, the force along the x-axis causes an acceleration along the x-axis, and the acceleration can be written as d2x upon dt2. Fine, this is a perfectly valid differential equation. And I can say Fy is equal to similarly d2y upon dt2 times mass. And I can similarly say Fz is equal to m d2z upon dt2. These are perfectly valid differential equations, and if we solve them, we can figure out something about the nature of the motion by figuring out x, y, and z. All right. Now, this is the Newton's second law in x, y, and z coordinate system, right? 1D के लिए x, 2D के लिए xy, 3D के लिए xyz. But if I move on from the xyz coordinate system, so let's suppose r theta phi. So it's called spherical coordinate system. Now my question to you is, can I write the Newton's second law in the same manner? By that I mean, can I write Fr is equal to m d2r upon dt2? Can I write F theta is equal to m d2 theta upon dt2? Can I write F phi is equal to m d2 phi upon dt2? बताइए. Are these correct equations? Are these correct? They are not correct. What is the correct expression? Anybody? पहला ही बता दीजिए रेडियल इक्वेशन का क्या होगा. व्हाट इज द करेक्ट रेडियल फोर्स इक्वेशन?
Sir, we can replace x with r sine theta and r cos theta like that. And
But we
for
cannot write it like this because here we have written it like this. Fx is equal to m d2x upon dt2. So can't I write fr is equal to m d2 r upon dt2? Is it, why is it wrong? Like these are also perpendicular directions. R theta phi, they are perpendicular directions.
R is not a constant unit vector. So that also changes. So you have to differentiate with respect to vector r hat. That is
Yeah, correct. Like, yeah. It's not constant in its direction. It keeps on changing as the particle is moving, as opposed to XYZ, which is kind of constant as a coordinate system, as well as X and the transformation relations between X and R are either X is equal to R cos theta, whatever. See, there is an important property when it comes to the Newton's laws. You know, the property is that the Newton's laws are not in its form. The Newton's laws in its form is not consistent across different coordinate systems. So if I go from like an XY coordinate system to a sort of a polar coordinate system or a spherical coordinate system, then the form of the Newton's second law, form की बात कर रहा हूं, ठीक है? The form of the Newton's second law does not hold. Okay, this is one of the problems of Newtonian mechanics. Now इसको resolve कहाँ किया जाता है? This is resolved by what is known as the Lagrangian formulation, as well as the Hamiltonian formulation. By when we reach maybe September, October, before your TIFR exams, I'll take a couple of lectures on the Lagrangian formulation. Maybe some of you are already familiar with the Lagrangian formulation. The fundamental equation of the Lagrangian formulation, which is the Euler-Lagrange equation, is coordinate independent. Means the form of the equation does not change. It doesn't matter what coordinate system you choose, whether you choose an XYZ coordinate system, whether you choose some spherical coordinate system, whether you choose some cylindrical coordinate system, whether you invent some new coordinate system, it doesn't really matter. The equation is consistent in its form. Newton's laws के साथ ऐसा नहीं है. Newton's laws क्या होता है? The moment I go from spherical Cartesian to spherical or Cartesian to cylindrical, its form changes, and that poses a fundamental challenge. ठीक है? It poses a fundamental challenge to how we apply the Newton's second laws. क्यों? क्योंकि now that if you are going to do some problems related to circular motion or spherical or cylindrical motion, then you cannot just substitute these equations as it is. You need to know the exact expressions. You need to memorize them. You need to remember them. अगर आपको नहीं पता तो फिर you will be confused. And this is one of the challenges that most students face. They don't really know how to represent the force equation along the radial direction. नहीं पता. आप लोग को पता है what is the force equation along the radial direction? आपको पता है what is the transverse force equation, force equation along the transverse direction? पता है? पढ़ा तो होगा, but याद नहीं है. I'm damn sure that class 12th में भी आप लोगों ने पढ़ा होगा somewhere, but you don't remember it because you never gave it importance. You just thought, oh, centrifugal force वगैरह वगैरह. Forget about centrifugal forces. I don't want to hear about centrifugal forces, not up till rotation. I know that you guys have a habit of using centrifugal forces. I also have, not a big problem, but forget about it. I want to come up with something more fundamental, basically. What is that? That is the force equation along the radial direction. That is the force equation along the transverse direction. I mean, we will see that the term corresponding to centrifugal forces as well as other terms will be inherent in that equation. It will be inherent there. So you don't have to remember it separately, apply it separately. It will be inherent in those equations. Okay? So I want to come up with the force equations. If this is not correct, then I want to come up with the force equations for different coordinate systems. And then what I'll do is I'll ask you guys to memorize it. I'll ask you guys to make a formula sheet and write it down so that every time you do a problem related to polar coordinates or circular motion or kinematics in circular motion or force equations in circular motion, you just bring it back from memory and then you apply it appropriately. Okay? So to build that, I want to spend some time with the theory first. So let us start with the most simplistic coordinate system, and then I'll just give you the solution, like the final transformation equations for the other coordinate systems. इतना time तो होता नहीं है pure derivations के लिए. I'm sure कि college में आप लोगों ने किया होगा derivations mathematical physics के classes में. But here I'm going to do the derivation associated with polar coordinates first. That will give you a general idea of how to sort of approach this subject. What is polar coordinates? Polar coordinates is essentially spherical coordinates, but only when we are considering 2D motion. So we are only interested in r and theta for the time being. Okay. So what is a coordinate system? You see, coordinate system is very, very important because we want to study motion. Mechanics mein, we want to study motion. But to study motion, we must define certain quantities. You know, we must define position, first of all. Because if we cannot define position, we cannot define velocity, then we cannot define acceleration. Position has to be defined, but position is always defined with respect to a sort of a mathematical geometrical construct. There is no absolute position, right, of anything. It is always defined with respect to a coordinate system. So the geometrical construct is called the coordinate system. So when we talk about XY plane, that is also a geometrical construct, right? So when we talk about an XY plane, so if we are interested in, let's suppose, the motion of a sort of a 2D motion, right? We are talking about a geometrical construct. There's nothing wrong with that geometrical construct. Okay? But there are sort of peculiarities involved in every geometrical construct, and we must understand sort of what is the distinction, right? So let us look at the comparison between XY coordinate system versus a polar coordinate system. So let's say that this is XY coordinate system, and let's say this is also XY, but this is more of a comparison between X and Y. So what is this coordinate system? It's like a grid. Okay, the XY composed of a grid of parallel lines intersecting each other at 90 degrees. So I can think of this XY as a grid of parallel lines. So this is one line parallel to the Y axis. This is another line parallel to the Y axis. This is another line. So we can sort of draw these kinds of line along the X axis, which is, by the way, real axis. So every single point, so infinite lines. Okay. So you guys have used a graph paper in the lab. लैब में आप लोगों ने ग्राफ पेपर खरीदा होगा, मे बी लैब स्टाफ ने आपको ग्राफ पेपर दिया होगा कभी when you are about to plot something, right? You have used a graph paper, right?
Yes, sir.
The graph paper looks like this only, isn't it? You have a scale along the y-axis, you have a scale along the x-axis, and then there are grids. And then along the grids, you have a units. So you associate x-axis with some physical quantity, maybe distance, maybe time, maybe some other physical quantity. And then you associate the y-axis with some other physical quantity, you know, and then basically you try to find out that particular coordinate of one physical quantity corresponding to the other. You draw a dot, and then you draw other dots, and then you connect those dots. You find the relationship between those physical quantities. So that is what the XY plane is. It's quite simply put, this kind of a rectangular grid. It's just that we are limited to lengths, or we are basically interested in the position of the particle or tracing out the position of the particle, right? So if, let's suppose, this is our XY plane, and the XY plane is centered around O, and we're looking at the motion of a particle across this particular surface, and at a given point in time, the particle is somewhere here. Okay? At a given point in time, the particle is somewhere here. Then what we say is that we say that the particle has the coordinates x comma y, where this is the x value, this is the y value. So we look at the projection of that particle, or rather the vector of that particle from the origin along the x-axis and along the y-axis. So we can draw a position vector to that point, and if we look at the projection of that position vector on the x-axis, we get the x coordinate. If we look at the projection of the position vector onto the y-axis, we get the y coordinate. So mathematically speaking, x and y these two numbers in a bracket contain the information about the particle's position in a given system with respect to this coordinate system. And this x and y can be a function of time if the particle is tracing out a path with respect to time. Okay? So the coordinate system gives us a way of quantifying the position of the particle as the particle is moving through space. That's all. Nothing else. इसमें कुछ बहुत अलग सी बात नहीं है. That's it. So this is the position vector r. Okay. Now, what we can do is we can take this r and we can talk about various quantities. So if we have a position vector, which is nothing but r, that is denoted as xi cap plus yj cap. Again, I'm doing this analysis in 2D because it's sort of easier. I can define other quantities. I can define the velocity vector. The velocity vector is quite simply put the time derivative of the position vector. X dot I cap plus y dot j cap. I can also define the acceleration vector. The acceleration vector is the time derivative of the velocity vector. So x double dot I cap plus y double dot j cap. I can go on further. I can do a time derivative of the acceleration vector. Anyways, the point is that this coordinate system gives us a sort of a base, sort of a construction upon which we can build our physical theory. We can define position, we can define velocity, we can define acceleration. We can figure out, we can then write down the dynamical equation, which is the Newton's second law. We can solve it, we can play around with it, and we can have as much information about the system as possible, right? But this geometrical construction of how we are defining the position of a particle at a given point in time is not absolute. It's just a choice, right? It's a choice. There are other options as well. And the other option I mean is the polar coordinates. So the polar coordinates, the way we measure position or we define position is slightly different. So for example, if a particle is in the same sort of a here, okay, position here. Okay, what I do is, let's suppose this is the origin and I draw a position vector from here to here. Okay, this is the position vector. But now, how do I write the position vector in detail? For that, I will have to define a new sort of an axis. So here in polar coordinates, we have the axis called the radial axis and what is called the transverse or the azimuthal axis, which gives us an idea about the angular displacement. Okay, so radial axis is essentially if I go in this direction, which is the direction of the position vector, this is the radial axis. That's it, nothing else. I hope you can see this. The radial axis is the direction along the position vector, outward, nothing else. We can call it r cap, or I can call it the radial axis. Notice here that the radial axis very much depends on the position of the particle. Particle agar yahan pe hoga, so radial axis is in this direction. Okay, so the radial axis is not a constant. It keeps on changing as the particle is in motion. And the transverse axis, all right, the transverse axis is simply perpendicular to this radial axis here. So you can go from here to here. So this is theta cap. Okay, theta cap is the transverse or the angular, tangential direction or axis. Okay, and how do we define this sort of a transverse or this tangential axis? We define it as the axis which is perpendicular to the radial axis. But what is the component of the sort of position vector associated with these axes? The component of the position vector associated with the radial axis is very simple. It is the length of the position vector. That's it. If you calculate the length of this position vector, which goes from basically 0 to the point P, if this is point P, that gives you the radial displacement, right? But what about theta? For theta, we need to choose some kind of a standard reference direction. And we usually choose that standard reference direction for the sake of simplicity to be what is called a polar axis. So if we call this as a polar axis, then with respect to the polar axis, we can say the angular displacement of this is theta. That's it. Two important things. In polar coordinates, the distance between the origin to the instantaneous point is the radial displacement, and the angle that that position vector makes with a fixed direction, also called the polar axis, is called angular displacement. And the direction of the radial vector is along the outward radial direction, and the direction of the sort of angular displacement quantity is along the tangential direction at that particular point. That's it, nothing else. So now what we can do is we can go from a Cartesian coordinate system to polar coordinates. We can go from Cartesian coordinates to polar coordinates. And mathematically, there are what is called the transformation equations involved. So in Cartesian coordinates, we used to have these two numbers, xy, where a position vector is written in this manner. And in polar coordinates, we have r and theta, where I want to find out the same thing. How can we write the position vector, velocity vector, and the acceleration vector in polar coordinates? And as a result, I want to find out the force equations in polar coordinates. All right. All right. So let's start. यहाँ तक clear है बेटा? You are following the discussion? Understanding the setup of the whole topic? Following the discussion?
Yes, sir.
Yes, sir.
Yes, sir.
All right. So let's start with the transformation equation. The transformation equation simply gives us a mathematical relationships between xy and r theta. So if I know xy, I would like to find out r theta, and if I know r theta, I would like to find out xy. Okay, so this is basically r is the radial distance, and theta is the radial displacement, radial coordinate लिख देता हूँ, better रहेगा. R is the radial coordinate and theta is the angular coordinate. Okay, so it is kind of clear from the geometry of this setup that x is going to be equal to what? Because I can also find out x here. What is this? X is a projection of the position vector on the x-axis, and the y, what is y? Y is a projection of the position vector on the y-axis. So tell me, what is x? What is x?
R cos theta.
Theta.
What is y?
R sin
R
theta.
sin theta.
R sin theta. All right. So this will give us an opportunity to figure out the other relationships. So if I have x is equal to r cos theta and y is equal to r sin theta, then this is the transformation relationship on one side. So for example, if I know r and theta, I can go to x and y. If I know r and theta, I can calculate x and y. But what if I know x and y? Then can I calculate r and theta? That also we can find out. Okay, so we can find out using, so if I say x square plus y square, this will give us r square cos square theta plus r square sin square theta is equal to, sin square theta plus cos square theta is equal to 1. So therefore we will have r square. So therefore we have r is equal to x square plus y square root over. And if I say y upon x, this will give us r sin theta upon r cos theta. So this is equal to tan theta. So then I can say, or theta is equal to tan inverse y upon x. So these are the reverse transformation equations. These are the reverse transformation equations. Okay, you need to be aware of both of them. These are reverse transformation equations. Essentially, if you want to go from r theta to xy, these are your transformation equations. If you want to go from xy to r theta, then these two are your transformation equations. Okay, अपने formula sheet पे आप इसको mention करके रखना. I hope that you have started maintaining a formula sheet for every subject. So because formula sheets are very helpful. Later on, you are going to forget a lot of things. So sometimes when you just look at the formula sheet, things come back. You sort of, it gives you a quick refresh. So maintain a formula sheet and write down these formulas in your formula sheet so that you do not forget them. Now, once we have defined these transformation equations, as we go from Cartesian coordinates to polar coordinates and vice versa, now my challenge is, how can I represent the various sort of various physical vectors, various physical vectors. So now let us construct this problem. So let us do a little bit of a theoretical discussion here. Sir, why Newton's second law is wrong in polar coordinates? Because in Cartesian coordinates, x and y is constant, but in polar. So, Akash, I am not saying that the Newton's second law is wrong. So, I'm not saying it's wrong. It's not wrong. What I'm saying is the form of the Newton's second law is not consistent across the coordinate system. Form is not consistent, but it doesn't look the same. We cannot reduce the Newton's second law to an expression that is consistent across the coordinate systems. Are you understanding? मतलब हमारा जो इक्वेशन है जो हम न्यूटन सेकेंड लॉ में लिखते हैं दैट इक्वेशन इज वेरी मच पर्टिकुलर टू द कार्टेशियन कोऑर्डिनेट्स. देयर आर अदर फॉर्म्स ऑफ द न्यूटन सेकेंड लॉ इन स्फेरिकल एंड सिलिंड्रिकल कोऑर्डिनेट्स जो मैं आपको दूंगा बाद में. They look very different. They look very complicated. They look like something that you would not be able to memorize it easily. So this is a form of the Newton's second law that has a very peculiar form in the Cartesian coordinates and sort of different form in other coordinate systems. It's not wrong as a law, as a physical law, it's not wrong. Physical law, it's perfectly valid. As a mathematical equation, the form changes when we go from one coordinate system to another coordinate system. Okay, and one reason, of course, is yes, the position vectors do not sort of remain constant here. But let me derive it for you. Let me derive it. So particle executing motion along a trajectory. Okay, आगे बढ़ते. So I have this coordinate system which is the xy, but मैं इसको डिनोट करूंगा तो ऐसे लिख रहा हूं ताकि हम दोनों के बीच में कोरिलेट कर पाए. And let's suppose that there is a particle here. Particle is experiencing some sort of a motion, Particle is going somewhere. All right. So the particle is going somewhere. The position vector is this one in both the coordinate systems. Now, if we look at the position coordinates, let's suppose this is theta. Okay. This is xy. And this is r. So if we look at it, the particle's position is given by xy in the xy coordinate system that has the unit vectors of, this is the I cap direction, this is the j cap direction. Now, if I make a comparison with the radial vectors, the radial vector will be in the outward direction, and the vector along the transverse direction will be in this particular direction, so theta cap. So geometrically, if this is theta, then so is this, and so is this. Okay, these are all theta. Now I want to find out the relationship between I cap, j cap, r cap and theta cap. इनके बीच का जो relationship है, we can quickly find it out. Akash, so if we think only in polar coordinate system without knowing that in Cartesian coordinate system, then the second law is correct in that polar form. Yes, the second law is correct in the polar form, but the expression is slightly different. I will give you the final expression once I have completed my derivation. I'll give you the final expression. See, the thing is, when I say F is equal to MA, now this itself is perfectly valid because here I have not specified what is the coordinate system, Akash. Okay, only the problem is when I try to write it respect to a coordinate system like this or like this, that is where the challenge happens. ठीक है, अगर मैं एक जनरल वेक्टोरियल नोटेशन में लिख देता हूं न्यूटन सेकंड लॉ को, तो मैं बस इतना लिखूंगा, यहां पे कोऑर्डिनेट सिस्टम का कोई इंफॉर्मेशन नहीं है. दिस इक्वेशन इज परफेक्टली वैलिड only when I try to write it in the context of a Cartesian system or in the context of some other system. The Newton's second law takes some unique form that is only valid in that coordinate system. Okay, Akash, does it make sense? Akash, is your doubt clear? Yes, okay. तो ये इसमें मैं इसको मैं क्वेश्चन नहीं कर रहा हूं. आई एम जस्ट सेइंग if I write it in a very specific coordinate system xyz or r theta phi, it changes its look, its form. So now from the geometry of this configuration, I want to write down r cap as a vector in terms of I and j. So if I write r cap as a vector in terms of I and j, can I write r cap as cos theta I cap plus sin theta j cap? बताइए, yes or no? Can I write it like this?
Yes, sir.
And if I write theta cap can be written as, theta cap इस तरफ है, ठीक है, नेगेटिव आई एक्सिस में है, so I can write theta cap as minus sin theta I cap plus cos theta j cap. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Minus comes because it is along the negative x-axis. Okay, it is along the negative x-axis, इसलिए minus आ गया. So let's say this is point number 1 and let's say this is point number 2. Now, before we move forward, let me also derive a couple of these things. The time derivative of r cap and theta cap. So if you look at the time derivatives, so dr cap upon dt, this can be written as d by dt of cos theta I cap plus sin theta j cap. So this becomes minus sin theta. Now what is the derivative of I cap? It is 0, right? So there are 3 terms here. So the derivative of I cap is 0, so that term is not going to be present. But theta is changing, so the derivative of cos theta is going to give us sin theta and d theta upon dt I cap. And similarly, here we have cos theta and d theta upon dt j cap. So this becomes minus sine theta I cap plus cos theta j cap times d theta upon dt. Okay, so what is this? Minus sine theta I cap plus cos theta j cap. It is nothing but theta cap. So therefore, this is equal to d theta upon dt is theta dot theta cap. बताइए, yes or no? This is r dot cap. Are you understanding this equation? Yes or no? बताइए.
Yes, sir.
It's a simple mathematical equation. Is a simple mathematical equation that gives us a relationship between the time derivative of the r and theta cap directions with respect to x and y directions as the particle is moving forward in time. The reason that we in fact have a relationship like this is because the radial and the transverse directions do not remain a constant. The x-axis and y-axis are always a constant as the particle is moving. Doesn't matter, the motion of the particle does not affect the directions of I cap and j cap, but the motion of the particle does affect the directions of r cap and theta cap. So if the particle reaches here, r cap direction and theta cap direction will also change. And it is because of this reason we have these relationships between r ij and theta ij. Okay, so this is the first relation. You don't need to memorize it outside the class. I'm only going to use it in the context of today's derivation. उसके बाहर इसको याद रखने की जरूरत नहीं है. And let's also find out d theta cap upon dt. So if I do this, d upon dt of minus sine theta I cap plus cos theta j cap, this is going to become minus cos theta d theta upon dt I cap minus sine theta d theta upon dt j cap. So this becomes minus cos theta I cap plus sine theta j cap, and then you have d theta upon dt. So what is this cos theta plus I plus sine theta j? It is nothing but r cap. Okay, so if I substitute r cap here, I simply end up getting minus r cap. So this is theta dot r cap. So this is theta cap dot is equal to minus theta dot r cap. No, sorry, not theta dot r cap. Yes, correct, theta dot r cap. Minus sine theta plus cos theta is theta cap, and cos theta plus sine theta is r cap. Yes, minus theta dot r cap and theta dot theta cap. Okay, these are the time derivatives. Let's say this is point number 3 and this is point number 4. Okay, all right, so this is the time derivatives. Now let's use the time derivatives to figure out the various physical vectors that we have to sort of take a look at. So first we'll go into position coordinate or position vector. Okay, I already told you that in Cartesian coordinates, the position vector is written in a very simple manner. It is r is equal to x I cap plus y j cap. Okay, in xy plane. So this is in xy. But what is x? X is equal to r cos theta I cap plus r sin theta j cap. Then this can be written as r common cos theta I cap plus sin theta j cap. So what is cos theta I cap plus sin theta j cap? It is r cap. So therefore this is nothing but r vector, position vector is given by r cap. That's it. This is an important expression. Remember this. This is in r theta coordinates. This is the position vector of a particle in r theta coordinates. कोई क्वेश्चन है यहाँ पे? बताइए. होना तो चाहिए वैसे. नहीं है.
हाँ मतलब सर पोजीशन को डिस्क्राइब करने के लिए यहाँ थीटा की कोई जरूरत नहीं है.
नहीं है. Very good. See, the obvious question is, why don't we need theta to describe the position of a particle? Because the r cap already contains the information about the theta. समझ रहे हो?
Yes,
R
sir.
cap already contains the information about the theta. So let us move on to the next quantity, which is velocity vector. Which is V is equal to x dot I cap plus y dot j cap. So what is x dot? D upon dt of अच्छा नहीं, इसको I cap j cap रह जाएगा ना. Let's write it in this manner. It is dr upon dt. So this is equal to d by dt of r cap. So this is in xy. This is in xy. And so this can be written as r cap plus r dr cap upon dt. Okay, so this is nothing but r dot r cap plus what is dr cap upon dt? We already obtained in point number 3 is theta dot theta cap. Using point number 3, theta dot theta cap. So r theta dot theta cap. So therefore, the velocity vector in polar coordinates is given by r dot r cap plus r theta dot theta cap. This is a very important expression. Very important expression. So this is in r theta. Are you noticing the difference here? When I write the velocity vector in xy, it is simply vx I cap plus vy j cap. So vx is nothing but x dot and vy is nothing but y dot. Okay? But when I write the same velocity vector in polar coordinates, it is vr r cap and v theta theta cap, jahan pe vr is nothing but r dot and v theta is nothing but r theta dot. So this is what's important. Vr is r dot and v theta is r theta dot. So vr का मतलब है the velocity component along the radial direction and v theta का मतलब है the velocity component along the angular direction. So we have some sort of unique words, names associated with it. Okay, so if we look at this, this is nothing but it's called radial speed. Vr को हम बोलते हैं r dot, which is nothing but dr upon dt, and v theta is nothing but r theta dot, which is r d theta upon dt. This is called radial speed, and this is called transverse or tangential speed. Radial speed, transverse और tangential speed. ठीक है, याद रखना, बहुत इंपॉर्टेंट है, वेरी इंपॉर्टेंट. हमेशा पोलर कोऑर्डिनेट से रिलेटेड कुछ ना कुछ क्वेश्चन तो जरूर आ जाते हैं, एंड इट्स एक्चुअली वेरी इजी. इट्स नॉट वेरी डिफिकल्ट एट ऑल. Once you just understand that there are a little bit some additional terms involved and additional formulas involved, things fall into place. So radial speed basically gives you an idea about the magnitude of the speed along the radial direction. So for example, if you look at a particle, okay, if you look at a particle's motion, okay, the particle is, let's suppose, making some sort of a motion. So if I look at the particle's motion at any given point, आप लोग को पता है, physically speaking, that the speed component along the x-axis is basically called vx, है ना? And the speed component along the y-axis is called vy. But right now what we have found out is the speed component along the radial direction, that is vr, and the speed component along the transverse direction, that is v theta. So vx and vy are not the same as vr and v theta. Keep in mind, please. They signify something else. We can combine them to come up with the same overall speed, no problem. So velocity vector ka overall speed hai, we can combine vx vy to get v. So basically what we can do is we can say that vx square plus vy square root over is going to give us what? Nothing but the velocity vector magnitude, which is essentially the speed of the particle. But that can also be obtained by vr square upon v theta square root over. So if I work in xy coordinate system, this is going to be the speed. If I work in polar coordinates, this is going to be the speed. So overall speed of the particle remains the same. But if I just look at the components involved, they are not the same. They're something else. So the radial speed is a speed along the radial direction only, and the transverse speed is a speed along the tangential direction. So this is the linear speed along the outward radial direction, and this is the speed along the tangential direction or the angular direction. ठीक है, जैसा भी आप इसको बोलना चाहते हो. Very important formulas, guys. You will see that in the coming lectures. मैं आपसे पूछूंगा, बताओ रेडियल स्पीड का फॉर्मूला क्या है, ट्रांसवर्स स्पीड का फॉर्मूला क्या है, एंड यू नीड टू हैव इट लाइक दिस इन योर माइंड. ठीक है, यू हैव टू मेमोराइज दिस. क्लियर है? बताइए, कैन वी मूव फॉरवर्ड?
Yes, sir.
Similarly, I have obtained the velocity vector expression. I also want to obtain the acceleration vector expressions. What is the acceleration vector? The acceleration vector is simply going to be d to r, instead of doing a double derivative, let's write dv upon dt. Okay, so this is going to be d by dt of v. What is v? V is r dot r cap plus r theta dot theta cap. R dot r cap plus r theta dot theta cap. So now if I do the time derivative, this is going to be d to r upon dt to r cap, right? D to r by d theta to r cap plus r dot dr cap upon dt plus dr upon dt theta dot theta cap plus r d2 theta upon dt to theta cap plus r theta dot d theta cap upon dt. Okay, so this is r double dot r cap, and this is r dot. So what is dr cap upon dt? Dr cap upon dt is dr cap upon dt is theta dot theta cap. थीटा डॉट थीटा कैप, ठीक है, यहाँ पे हमने सब्स्टिट्यूट कर दिया. एंड हियर वी हैव r dot theta cap, and here we have d by dt of so this is theta double dot, and this is r theta dot, and here we can substitute d theta cap upon dt from point number 4 minus theta dot r cap. This is minus theta dot r cap. So if I combine everything, r cap के अंदर क्या आएगा? r cap के अंदर आएगा आपका ये और ये, इन दोनों को कंबाइन कर देते हैं तो r डबल डॉट माइनस r थीटा डॉट स्क्वायर r cap, एंड थीटा डॉट क्या, थीटा कैप के अंदर क्या आएगा? ये तीन टर्म्स आएंगी, which together means r theta double dot plus 2r dot theta cap. This is the angular acceleration vector in polar coordinates. Acceleration vector in polar coordinates. So you have these two expressions. This is the radial acceleration. This is the transverse acceleration. Now again, keep in mind, जब मैं यहाँ पे आपको ये बता रहा था, as a particle is in motion, particle has a certain kind of a velocity in a certain direction, right? It has a certain kind of a acceleration also in certain directions. So the acceleration component along the radial direction and the acceleration component along the transverse direction, that is what we have obtained here, okay? And if we write it in detail, this is AR. So usually क्या होता है? Acceleration में हम क्या लेते हैं? Acceleration में we say that acceleration A is equal to, you know, AX I cap plus AY J cap, which is basically X double dot I cap plus Y double dot J cap. Okay, this is in XY coordinates, in XY. But if we write it in r theta we write it as AR r cap plus A theta theta cap, which is basically this जो मैं अभी लिख रहा हूँ, AR and A theta. So what is AR? AR is equal to R double dot minus R theta dot square, and A theta is equal to R theta double dot plus 2R dot theta dot. ये एक्सप्रेशन याद रहेगा? बताइए.
बहुत मुश्किल,
लेकिन रखना पड़ेगा. You have no choice. It's very important. Very important.
Yes, sir.
ठीक है. You might, if spherical coordinates के लिए अगर याद नहीं रहे तो शायद ज़्यादा दिक्कत नहीं हो सकती है. But polar coordinates में आपको याद रखना ही पड़ेगा, because many questions that you see will require that you know the radial and the transverse acceleration from memory. You have no choice. You have to memorize this. Okay. Very important. Please
Yes, sir.
memorize it, guys. Okay. Very important. मैं क्या करूँ? Highlight कर देता हूँ. Very important. बहुत सारे क्वेश्चंस आते हैं. जैम में तो आते ही हैं. Related to polar coordinates, and if there's some acceleration term, you will have to remember it. Now I can go a little bit in detail and give you some additional information here. So for example, what is this R double dot? R double dot is nothing but what is, it's not AR, but it's simply you can say that this is the linear acceleration along radial direction. Now what is R theta double dot theta square? ये क्या है बताओ? ये तो देखा होगा.
ये सर सेंट्रीफ्यूगल
सेंट्रीपिटल एक्सेलरेशन. ठीक है. आप लोग जब भी प्लैनेटरी मोशन करते हो तो आप ऐसे करते हो ना, फोर्स का तो उसी का टर्म है ये, नथिंग एल्स. What is r theta double dot? This is linear acceleration along transverse direction, and what is 2r dot theta dot? 2r dot theta dot. It is nothing but what is called Coriolis acceleration. Don't worry about it. If you don't remember these names, doesn't really matter. Doesn't make a difference. What I'm trying to say is that you need to stop sort of thinking about centrifugal forces and Coriolis forces. They simply arise as a result of circular sort of platforms experiencing some sort of a rotation. And because we have gone from a sort of a perpendicular xy Cartesian coordinates to a polar circular coordinates, therefore these terms automatically arise in the mathematics of everything. All right. So now that we have obtained the acceleration expressions, I want to obtain the force equations. Haji, question?
Sir,
Yeah.
here the transformation equation. So in which frame of reference I am in? I am in a inertial frame of reference and non-inertial frame of reference when I am using this transformation equation, because the centripetal force and the Coriolis force are the pseudo force. So I must be in a non-inertial platform when using this
You
equation.
must be in a rotating platform. Yes.
So, but in this, when deriving this equation, I did not use that I am in a rotating platform or thing like that. Did we?
No. So we have not yet studied rotating platforms. What I'm saying is, when we study rotating platforms, these are the terms that will reflect there. That's all I'm saying. Because essentially, हमारा जो ये coordinate system है, it is a circular. एक तरीके से there is a certain amount of circular symmetry. So when we rotate something, the rotation also has circular symmetry. The rotation involves a rotation about an axis passing through the origin. And when we talk about rotation, we talk about radial distance, we talk about angular displacement. So the mathematics is kind of similar. So the terms that I'm seeing here will arise later on when we look at everything from a rotating observer's perspective also, is what I'm saying. तो ये जो टर्म्स है ना, ये जब हम रोटेटिंग ऑब्जर्वर के पर्सपेक्टिव से कैलकुलेशंस करेंगे तो वहां पे भी ये टर्म्स अराइज होंगे, बिकॉज रोटेटिंग ऑब्जर्वर में भी एक तरीके का इस तरीके का सर्कुलर एक कंस्ट्रक्शन होता है जहां पे ऑब्जर्वर जब किसी ऑब्जेक्ट को देखता है विच इज रोटेटिंग, द रोटेटिंग ऑब्जेक्ट हैज अ रेडियल डिस्टेंस, द रोटेटिंग ऑब्जेक्ट हैज एन एंगुलर वेलोसिटी. So therefore, we automatically are in the presence of a polar coordinate system the moment we study rotation. Rotations usually we do not study in Cartesian coordinates. हम जब rotation study करते हैं, we study from the perspective of polar coordinates only. We talk about angular displacement. We talk about radial displacement. We talk about the omega being along the, passing through the origin and going along a particular direction. Are you understanding? So therefore, जब हम रोटेशन की बात करते हैं या रोटेटिंग ऑब्जर्वर की बात करते हैं तो ये पोलर कोऑर्डिनेट्स के मैथमेटिक्स में जो कुछ टर्म्स अराइज हुए हैं वो टर्म्स भी बाद में वहां पे अराइज होंगे. ठीक है. सो इफ यू आर अनेबल टू कनेक्ट द डॉट्स, फॉरगेट व्हाट आई सेड, डोंट वरी अबाउट इट. यू विल कनेक्ट इट लेटर ऑन व्हेन वी स्टडी नॉन इनर्शियल फ्रेम्स. ठीक है. मेक सेंस? नो?
Yes, sir.
All right. Now let's go back to our original question. All right, Prayog, no problem. Let's go back to our original question, which is, what is the force equation in polar coordinates? ठीक है. तो force equation को अभी हम लिख सकते हैं. Now we can write down the force equation very easily, right? So now we want to write down the force equations. So in xy coordinates, we have F is equal to ma. If I write it along x-axis, we have fx is equal to m x double dot ठीक है, or let me write it as max, which is equal to mx double dot, and fy is equal to may, which is equal to my double dot. ठीक है, but in polar coordinates, we have the same Newton's second law, the general expression, but the moment I write it in the context of this coordinate system, it becomes fr is equal to ar, which is equal to, what is ar? Ar is equal to r double dot minus r theta dot square. R double dot minus r theta dot square. And what is f theta? F theta is equal to m a theta, which is equal to, what is a theta? R theta dot double dot plus 2 r dot theta dot. Okay, r theta double dot plus 2 r dot theta dot. This is it. This is the force equation in the radial direction, mr double dot minus r theta dot square. And this is the force equation in the transverse or the tangential direction, mr theta double dot plus 2 r dot theta dot. So now if we start doing calculations in polar coordinates, instead of writing the net force in this particular manner, okay, we need to start writing in this particular manner. What do I mean by that? So if we go back to some of our case studies, for example, हमने जब lecture number 2 में करा था, like let's look at this problem, inclined plane problem. You remember the inclined plane problem? तो मैंने ये वाला equation लिखा था, fx is equal to ma and fy is equal to this. Remember? So मैंने इसको बहुत ज़्यादा detail में नहीं लिखा था. What I essentially meant was fx is equal to max. This is what I meant. So I was talking about the acceleration along the x-axis. So the whole problem has been done with respect to xy coordinate system. But if I study some problem that involves some circular motion, for example, I will give you an example at the end of the class. I think I will have some time, I guess, to discuss, let's suppose, simple pendulum. Then I won't be using the simple f is equal to max. What I will be using is, I will be using fr is equal to mr double dot minus r theta dot square, and I'll be using f theta is equal to mr theta double dot plus 2 r dot theta dot. So therefore, these expressions are very important. You better write it down in your formula sheets and you remember them. If you remember them, problems involving circular motion, and especially problems of free body diagrams involving circular motion, are going to be very, very easy for you. Very easy for you. मतलब बहुत सारी complications आपके लिए remove हो जाएंगी, and you will find many problems to be very easy to do now. Okay, so these are the force equations in xy and polar coordinates. बताइए, यहाँ तक कोई question है? Krishnika sir, can you show the acceleration vector in the graph one so it's easy to visualize? So basically, Krishnika, it's the same thing, right? If I look at the motion of a particle, then if I say Vx or Vy, or if I say, let's suppose, Ax or Ay, then they are the component of acceleration along the x and y axis. But similarly, if I say Vr and V theta, they are along the r cap and the theta cap direction. And if I talk about AR also will be in the radial direction. AR.
I was just asking about this r double dot, then r theta dot square, r theta double dot, इन सब के बारे में मैं बोल रही थी. एक बार अगर, if it's possible.
Oh, they are in the same direction only. Because this is part of r cap, right? What is the direction of r double dot? It's r cap.
Yes, right. And r theta dot square?
It's r cap only, na? It's the component of r cap only, na?
Okay.
Are you understanding? So what happens is that there is a certain magnitude of acceleration that is associated with a particle which is moving along a circular trajectory. देखिए, it goes back to the question of maybe in class 9 or something, some teacher may have asked you a question that if I rotate a ball in a circular trajectory, like if I take a ball and spin it in a circular trajectory, but with constant velocity, then what is its acceleration? Now somebody may say, oh, velocity is constant, acceleration is 0. But then the teacher would say, no, even if the velocity, the speed is constant, if the object is moving in a circular trajectory, its acceleration is not 0. Yes or no? They say this, right?
Yes.
Where is that acceleration coming from? And then they will say, oh, the acceleration is associated with the constant changing of direction. You're not supposed to have changing direction. So acceleration is only 0 if the object is not changing in direction. But because it's moving in a circular trajectory, there is a change in direction involved. Okay. So, yeah, because of the change in direction, you can think of it in this particular manner. So R double dot is of course in the outward radial direction. This is R double dot. And R theta dot square is in this direction, right? If you remember, like from class 11th or something, you would do calculations of planetary motion, right? And then what will you say? Oh, there is a gravitational force. And then you will say, oh, it's equal to, the gravitational force is basically given by m v square upon r or something like that. Okay, क्या था? M theta dot square is m omega square. या mv square by r. So ओमेगा के टर्म्स पे लिखेंगे तो यही बन जाएगा, because v is equal to ओम. मैं अभी करके देता हूँ वो चीज. So that is where it is basically, that it's the to give you a precise answer, r theta dot square is in the radially inward direction and r double dot is in the radially outward direction. Okay. Now coming to circular motion, which v and the relationship between v and omega, we can also derive that. जल्दी से मैं derive कर देता हूँ. Circular motion. If motion is purely circular, okay, so let's say this is r, this is r क्या theta क्या, what not. So circular motion का मतलब क्या होता है? R is equal to constant. Okay, for circular motion. R is equal to constant for circular motion. So then what is going to be the velocity for a particle in circular motion? Velocity v is equal to, हमारे पास क्या था? This was the expression, r dot r cap plus r theta dot theta cap, right? So r dot r cap plus r theta dot theta cap. So if r is equal to constant, then r dot is equal to how much?
0.
0. So that means this is going to be 0. So therefore, v is equal to r theta dot theta cap. So for circular motion, velocity vector takes a very special expression, r theta dot theta cap. So if I want to find out the speed, so velocity vector जो speed है, v is equal to r theta dot. That's it. But what is theta dot? Theta dot is equal to d theta upon dt, which is also known as omega, right? So this is
Angular.
this becomes, yeah, angular speed. Yeah, this is the angular speed. Angular speed is not equal to the transverse speed, by the way. Okay, keep in mind, angular speed not same as transverse speed. They're not the same thing. So therefore, you have this expression, v is equal to r omega. V is equal to r omega. So the speed of a particle in pure circular motion is equal to its radius times the angular speed. That's it. And if we look at acceleration, A is equal to r double dot minus r theta dot square r cap plus r theta double dot plus 2r dot theta cap. So r double dot will also be 0. R dot is 0. So therefore this becomes minus r theta dot square r cap plus r theta double dot theta cap. So here you have radial acceleration. So then the radial acceleration becomes a is equal to minus r theta dot square. What is this r theta dot square? This is the acceleration due to changing direction basically. It's not going in one particular direction. So इसको लिख सकते हैं हम क्या? Minus r omega square. इसको लिख सकते हैं हम क्या? Minus omega is equal to v upon r. So v upon r
v square by r total.
v square by r. तो इसका जो corresponding force है Fr for a particle which is moving in a circular trajectory is basically equal to minus mv square up by r. तो ये आप यूज करते हो जब भी आप प्लानिटरी मोशन के प्रॉब्लम को सॉल्व करते हो, राइट? You say that if a particle is going in a circular trajectory, you automatically assume this force to be existing there. So where is this force coming from? It is coming from here. The moment you make a transformation from the xy coordinates to polar coordinates, this force term is always present. This force term is always present. Comes as a result of the mathematics of going from a Cartesian to a circular frame of reference. Okay. All right. And the other term is transverse acceleration. So this is AR, and this is A theta, is R theta double dot. जिसको लिख सकते हैं R omega dot. If angular speed is a constant, if omega is a constant, if object is moving in circular motion, but with a constant omega, so uniform motion, so then this is going to be equal to 0. फिर सिर्फ यही बचेगा, ठीक है? All right. बताइए, any doubt till this point? Have you understood? Akshay, I have a doubt in the problem of the last class of rotating inclined plane. Can you please elaborate that in the end of the class? I will show you the solution. Okay, Akshay, just remind me. I'll show you the solution. Yeah. Any doubt till this point? It was a long derivation, but I hope that you will take the conclusion seriously. Keep in mind that you need to remember the transformation equations of the coordinates. You need to keep in mind the position vector in polar coordinates, the velocity vector in polar coordinates, and at least you need to know the radial speed formula, transverse speed formula, and you need to know the formula for acceleration vector, and more specifically the radial acceleration and transverse acceleration. If you do not know, then you are going to sort of be finding certain kinds of questions that involve circular motion to be very, very difficult. All right.
Sir, please give some problems so we can solve.
You want me to do some more theory, or you want to go to a problem straight away?
No, sir, if you
Problem.
Theory और नहीं पढ़ाऊँ?
think it is necessary, then sir, please continue.
Okay, एक simple सा problem दे देता हूँ before I continue the theory. Just give me a moment. Simple सा problem दे देता हूँ. So try this question. Can you see this question? Particle is moving in a plane. At some instant, its radial speed is √3 times the transverse speed. If the speed of the particle is 8 meter per second, what is the transverse speed? Try it, okay? Just give me 2 minutes. I am just coming in a moment. तब तक आप इसको try करो and try to solve it. It's a very easy question. Just give me 2 minutes. B is the correct answer. Karthik, Riyansh, Monzurul, Rakesh, Ruchir, Yashwant, Chetna, Kashan, Kunal, Akshay, Bamdev, Vivek. Correct. All right, fine. करने की जरूरत है? Should I do it? जल्दी से कर दूं. This is a question on basic definitions. ठीक है? A particle is moving in a plane. At some instant, its radial speed VR is the radial speed is root 3 times the transverse speed v theta given. If the speed of the particle, speed matlab magnitude of velocity. Speed of the particle is 8 meter per second. Then what is the transverse speed? So speed is written as VR square plus v theta square root over is equal to 8. So this becomes VR is 3 v theta square root 3 v theta square plus v theta square is equal to 64. Therefore, 3 plus 1 4 v theta square is equal to 64. So v theta square is equal to 16. Therefore, v theta is equal to 4 meter per second. That's it. Done. Very simple. Option number B is the correct answer. Just a question that is based on definitions. Definitions of radial speed and transverse speed. And this is a kind of a question that you can get in the exam. मतलब जैम में 1 मार्क का क्वेश्चन तो ये हो ही सकता है. और अगर आपको ट्रांसवर्स स्पीड और रेडियल स्पीड का फॉर्मूला नहीं मालूम और अगर उसका कॉन्सेप्ट नहीं मालूम, you won't be able to solve this question at all. ठीक है? So there are many questions on circular motion. We will do more questions. Okay, let's finish the theory. Okay, let's finish the theory. Now, because I have already discussed polar coordinates, I want to finish the discussion. ठीक है, आगे बढ़े? Shall we move forward?
Yes, sir.
I want to finish the discussion by also including some other coordinate systems, so that this discussion I can borrow the spherical as well as cylindrical also later on. ठीक है, once I start, I will be able to borrow it from here. So let me include cylindrical coordinates also. Just give me a moment. Okay, so apart from the polar coordinates, some important coordinate systems are, just a moment. All right, can you see this? Can you see
Yes.
this? Okay, okay.
Yes, sir.
Okay, so we have done this derivation for polar coordinates. You have seen how lengthy it is. So you can do a similar derivation for spherical coordinates as well as cylindrical coordinates. Of course, it's a theoretical task, and if you're interested, you can check up some kind of a standard textbook like I think H. K. Das वगैरह में हो सकता है, I think, where you can sort of look at the transformation equations and you can do the derivatives of the various unit vectors along various directions, and from there you can try to find out the position vector, velocity vector and acceleration vector using basic definitions, and then you can come up with the force equations involved. ठीक है, तो सेम चीज जो है हमने पोलर कोऑर्डिनेट्स में किया है, that same thing can be done for spherical coordinate system as well as cylindrical coordinate system. I'm not going to do the derivation, they are quite lengthy, but I want to give you the final expressions, because the final expressions can sometimes be helpful. कभी कभी आ जाता है, and it's important to remember them. So what is the spherical coordinate system? The spherical coordinate system is essentially an extension of the polar coordinates. So in the polar coordinates, we simply had x and y, but now we also include z. So the moment we include z in spherical coordinates, apart from r theta, we have another coordinate called the azimuthal angle.
Which one is azimuthal, theta or phi?
So it depends. Basically, what happens is that when you look at the construction of the spherical coordinates in mathematical physics and in physics, it's slightly different. In mathematical physics, the theta and phi is sort of inverted. So here, phi is the polar angle. Sorry, no, phi is the azimuthal angle.
Master,
No,
in cylindrical coordinates,
no, yeah.
distance between z-axis and that point is that we can represent rho, right?
Distance between the axis passing through the origin and the point.
Okay, thank you.
So if, for example, the particle is here, then this is not rho. This is rho. So perpendicular distance from the axis.
Got it, Master.
Okay. So azimuthal, I'm a little bit not sure at the moment. You can check this and verify here. But I think theta is the azimuthal angle here in my diagram. So you will see in certain textbooks they have two conventions. In certain conventions they will use this as the theta and this as the phi. But the diagram I have here right now is using this as the phi and this as the theta. So I'm making a guess that this is the azimuthal angle and this is the polar angle basically. But you can cross check and tell me if he.
No, Master. In Griffin's electrodynamics, exact diagram is this.
Yeah.
Uh,
So they are
okay.
using this diagram, but if you take up some other book, maybe they might have an other diagram.
Yes, sir. The
I'm
theta
saying,
and phi are replaced.
yeah, I'm saying that in general, if you look at the literature, it's a combination of two different diagrams. So one is this diagram that I'm using, the other is a diagram in which theta and phi are interchanged. So you should be open to both the possibilities. Usually in physics textbooks, this is the diagram that you will find. And usually in mathematics textbooks, the diagram is interchanged. All right, so yeah, let me give you quickly the transformation equations and the various quantities involved so that you can sort of, if you need to solve in a problem, you can come up with the answer. Sir, we can interchange theta and phi in the problems. Usually this is what is used in physics related problems, okay? And mathematics related problems, the other one is used. Azimuthal is a horizontal angular displacement. Phi basically here. I'm not sure. Monzurul, you're saying it's phi here in this diagram?
Yes, sir.
Okay, okay then, okay. Because I got confused. Mathematicians use theta as the horizontal angular displacement. And here we are using phi as the horizontal angular displacement. Okay, fine, okay. Okay, now but from the diagram, it's kind of clear. What are the transformation equations here? So can you look at the diagram and tell me what is x? What is x from the diagram?
R sin theta cos phi.
R sin theta cos phi. What is y?
R sin theta R sin phi.
R sin theta sin phi. This is from the geometry, okay? And what
Yes,
is
sir.
z? Z
R cos theta.
r cos theta. Okay. Just like we found the reverse transformation equations, if you want, I mean, you can do this as a homework because now I have showed you for one case, you can do for the other cases as well. The reverse transformation equations are, so R is equal to x square plus y square plus z square root over, and theta is equal to tan inverse of root over x square plus y square upon z, and phi is equal to tan inverse of y upon x. Now these are mathematical transformation equations. You can keep it in mind, you can write it down in your formula sheets, but most importantly, I am interested in the velocity. This is something that you need to keep it in mind, okay? This is what I am interested in. Again, the procedure is the same way what we did in the earlier case. Find out a relationship between the time derivatives of r cap, theta cap, phi cap, and then substitute that into the position vector, and then take a time derivative of that position vector. You will get the velocity vector. Okay, so the velocity vector is given by v is equal to polar. First, no, both are same. So r dot r cap and r theta dot theta cap, they are the same. The next is r sine theta phi dot phi cap. So this is your radial speed. This is your transverse speed. This is your azimuthal speed. Okay, this is a new thing that you have now, azimuthal speed. ये radial, transverse. Same way, acceleration is difficult to remember. Just keep it in mind. अगर याद नहीं होता कोई बात नहीं. Usually मैंने नहीं देखा है in exams for them to for you to remember the acceleration quantities, but velocity tak to I have seen that they will assume that you need to have in your memory the various components of the velocity vector in spherical coordinates. Acceleration ka I have not really seen, but it's up to you. So acceleration is r, radial acceleration is r double dot minus r theta dot square minus r sine square theta phi dot square. R double dot minus r theta dot square minus r sine square theta phi dot square r cap. So this is the radial acceleration. R theta double dot plus 2 r dot theta dot minus r phi dot square sine theta cos theta theta cap plus r phi double dot sine theta plus 2r theta dot phi dot cos theta plus 2r dot phi dot sine theta phi cap. So this is the azimuthal acceleration. Okay, this one is the radial acceleration, this one is the transverse acceleration, and r phi double dot sine theta plus 2r theta dot phi dot cos theta plus 2r dot phi dot sine theta. I am just giving it to you because maybe it might be necessary sometime. All right, but these are the two physical quantities in 3-dimensional spherical coordinate system. Theta is polar angle. हाँ ठीक है, वही कहा मैंने. So basically this is the radial, polar and azimuthal. Now let's come to the cylindrical this thing. So you see, where do we use spherical coordinates? We use spherical coordinates whenever there is some sort of a spherical symmetry to some sort of a motion. So for example, if some motion is happening on the surface of a sphere or a surface of a hemisphere. So for example, अगर हम बोलते हैं कि there is a bowl and on that bowl there is some kind of a motion of a bead that is happening, So clearly there is a spherical symmetry to it, and it's better that if we want to study the motion of the bead which is rolling on a hemisphere of a bowl, it's better to use spherical coordinates. Polar coordinates कहाँ use करते हैं? Polar coordinates use करते हैं जहाँ पे there is some kind of a circular motion. For example, the motion of a simple pendulum. If we study the motion of a simple pendulum in the literature, you will see that they don't use xy coordinates. They use r theta coordinates. Now, same way, we can also use the cylindrical coordinate system for motion which has a certain amount of cylindrical sort of a symmetry. So for example, imagine that there is a object which is going in some kind of a helical path or something like this. Then there is a certain amount of cylindrical symmetry to it where we use what is called the cylindrical coordinates. So spherical coordinates में क्या होता है? You have these concentric spheres. Similarly, cylindrical coordinates में क्या होता है? You have these concentric cylinders. You understand a cylinder, right? So you have these concentric cylinders, and the coordinates associated with the cylindrical coordinate system is rho phi z. So you have on one hand the distance from some kind of an origin that is given by z, and you have on another hand the distance from the axis of the cylinder, which is given by rho. Rho is not the same as r. R is a radial distance, but rho is a distance from a perpendicular crossing through the cylindrical the surface. So the z axis है, z axis का जो perpendicular distance है, that is rho, and phi is the azimuthal angle as before. यहाँ पे जो azimuthal angle था x axis के reference में, that is the same in the cylindrical coordinates, but rho is different from r. Rho is the perpendicular distance from the axis, which is the z axis, and z is of course the displacement along the z axis. Okay.
Say rho is basically r sine theta, I guess.
Yes, rho is r sine theta. So rho is this distance. Ye r sine theta. You're correct. This is rho. It's the perpendicular distance from the z axis to the point. Okay. So now if you look at this system, the transformation equations are slightly different, but it's still doable. So if you look at the transformation equations, what is x here? X क्या है? X क्या है?
Rho cos phi.
So if this is the rho, then and this is the phi, then x is basically rho cos phi. Okay, y क्या है? Rho sin phi, and z is nothing but z itself. Okay, and the reverse transformation equations are rho is equal to x square plus y square root over, and phi is equal to tan inverse of y upon x, and z is of course equal to z. No issues. Now if you look at the various physical quantities like velocity and all, if you look at the various physical quantities, give me 5 minutes, let me complete this topic. Okay, so the velocity v is equal to rho dot rho cap plus rho phi dot phi cap plus z dot z cap. Not difficult to remember. Okay, rho dot is the velocity vector along the direction which is radially outwards but perpendicular to the z axis. Rho phi dot again along the phi cap direction, and z dot along the z axis. And acceleration A is equal to rho double dot minus rho phi dot square rho cap plus rho phi double dot plus 2 rho dot phi cap plus z double dot z cap. If you notice, It is easy to remember the velocity and the acceleration components in the cylindrical coordinates because they have a certain amount of similarity with respect to the polar axis. And why do they have a similarity with respect to the polar axis? Because essentially xy is transformed into rho phi, and then there is the additional z-axis. That's it. Are you understanding? So the cylindrical coordinate is actually a little bit more easier because you can think of the cylindrical coordinates as polar coordinates plus a z-axis. That's it. So if you have a polar coordinates plus a z-axis, so that way the expressions are easier to remember. Okay, so you can, so this is the acceleration in polar coordinates as well. You just substitute rho with r and phi with theta, you'll come up with the same expression as well as for the velocity. So it's easy to remember these expressions. Okay, so now the thing is, from now onwards, the questions that we are going to do are not necessarily going to be limited to XYZ coordinate system. We might have questions related to circular motion. We might have questions related to cylindrical as well as different kinds of coordinate systems. So, but I will not jump straight away to random questions. In the next class, we will be focusing our attention on problems related to free body diagrams in the context of polar coordinates. We will discuss free body diagram related problems in the context of polar coordinates. So polar free body diagram related questions हमने last time जो करा था, फिर से हम करेंगे, but in r theta coordinate system. ठीक है, और उसके बाद काइनेमेटिक्स वगैरह जब करेंगे तो we will combine different kinds of coordinate systems. ठीक है.